Can we rotate that?
So I'm Jack Wells from Oak Ridge National Laboratory. This is my second PASC. I'm happy to be here. The program calls for a panel discussion on sustainable software development and publication practices in computational sciences. We have a distinguished panel that will be introduced in a moment. I just want to give you a few comments and a little bit of a setup in terms of how we're going to organize the session. Please put your thinking caps on. We're going to take questions from the floor throughout our time. We're not going to wait until the end. And so I hope you will be thinking about questions and comments that you want to make, because to be sure you'll have an opportunity to ask it and contribute to the conversation. So the PASC, this panel is focused on the opportunity, the goal of the PASC papers program is to advance the quality of the formal communication between the related disciplines of computational science and engineering. So in simple terms, what this means is that the PASC Papers Initiative is focused on soliciting work on what you do and how you do it. There's also, part of this conversation has been that there's a difference in the publishing cultures between domain science and the computer science and computing science. The computer science community publishes in high-profile annual proceedings and major conferences, and these are highly desired talks. Many of these are sponsored by ACM, like this conference is. The domain scientists traditionally have focused on publishing the work in journals. Those are the highly desired publications. And conferences have been focused on community engagement, improving the work, broadening the voices that are heard, receiving direct feedback. And our conversation this afternoon is not about changing that in any way, but trying to understand how we can advance an engagement between computer science, applied mathematics, and domain science communities to the benefit of all. So the idea is that because we are together, we would have something to say to each other that would advance everyone's work to make it better. So how do we do this? Well, in part, PASC's answer has been through the combination of a conference paper submission and review, conference participation, what we're doing here today, and potentially post-conference journal publications. And now we're coming closer to the focus of our panel. The papers track was premiered at PASC 16 last year, very successfully. Professor Thorsten Höfler from ETH Zurich and Professor David Keyes were the co-chairs. This is the second year for the PASC paper track. And Thorsten and I'm Jack Wells from Oak Ridge, I think I said, we were the co-chairs for PASC 17. And we had over 40 papers submitted, and we accepted 13 into the papers track, and those were presented here over the last 2 days in 4 different sessions. So now I want to highlight what comes next, potentially. It's the long-standing ACM policy that publication of post-conference journal submissions is allowed. That following the conference, authors have the opportunity to further develop their papers for publication, for example, in a relevant domain-specific journal or some other venue. This is not a PASC innovation, but many journals, many professional societies have this policy, and in particular, ACM has this policy. So we are trying to highlight this policy to try to make this venue valuable to many people. So the journal paper, consistent with the policy, the journal paper should be expanded, an expanded version of the conference paper, and there's guidance in the policy, ACM, how to do this, by adding more complete description of the work, more examples, adding additional scope. It's largely up to the authors to expand this work. When the work is published, in order to avoid claims of self-plagiarism, if you will, what is required is that the original conference paper be cited in the subsequent expanded work. And this makes total sense. And as we've broadened the discussion, other journals, in particular the Computer Physics Communications, largely has this same policy goal. To facilitate a conversation about this, which may be new to many of us, we have reached out to journals in conversation to highlight this opportunity to see if they would help us think about how to make the most of a multidisciplinary platform such as this, and to be aware of the possibility to expand conference papers into larger journal submissions. In particular, we have representatives here today of the editorial board of Computer Physics Communications, CPC, the Journal of Advances in Modeling Earth Systems, James, and ACM Transactions on Mathematical Software, TOMS. And our panelists from this journal editor community include Professor Walter Deenan, Dr. Michael Haru, and Dr. Robert Pincus. And we'll get to the panel shortly. In order to try to facilitate the conversation, I've drafted some high-level questions. Hopefully they make some sense. They're not a particular script for our conversation, but as a way of getting started, I thought we would just offer these. I will just leave these up on the screen. Hopefully the panelists can also see the questions. This. And we'll begin introducing the panelists and begin the conversation. So what I would ask is that each of you would introduce your journal, introduce yourself, and say a few words about what the purposes of your journal are, and we'll take it from there. Okay? So, Walter, would you begin?
Okay. So I'm here representing CPC, Computer Physics Communications, where I am a specialist editor for the astrophysics, astronomy part. This journal has been established in '69, and its purpose from the onset was to publish computer programs that have been used in the physical sciences, in engineering and related sciences. The original plan was that it would only contain papers that present a program, and that program would then also be published alongside with the paper and would be part of a library. That has evolved. It was not sustainable in this form, so it also publishes other papers, but it's roughly 30 to 50% papers are still these sort of papers, and the programs are still published together with the papers. They are now under an open source license. And so the idea was to promote the transparency and reproducibility of software. If you submit a paper in this form, then also the reviewers are asked to review the software. So this is, I think, what I want to introduce. Should I go to answer some of the further questions?
Just let's pause right there.
Right.
So, Robert?
So I'm Robert Pincus. I'm an atmospheric scientist, and I'm the editor-in-chief of a journal published by the American Geophysical Union called the Journal of Advances in Modeling Earth Systems. It's a relatively new journal. It dates from 2009. It's open access. The goal of this journal is, roughly speaking, where the ideas of our discipline, so we're a discipline science journal, that's just maybe the first thing to say. So the goal of the journal is to be where the modeling aspects of our work meet the ideas that we're trying to express. So we publish all kinds of things. Lots of it is sort of straight up analysis. We do publish some amount of work that describes programs, that describes computer programs. In our case, many of those have evolved or have a very sort of a deep history to them. And so we're rarely starting sort of from scratch. There are other journals which are similar, in particular one which is published by the European Geophysical Union called a Geoscientific Model Development. And we distinguished ourselves a little bit from that journal in the sense that our goal is to advance the practice of modeling. That means a lot of different things, but sort of in particular what it doesn't necessarily mean is something which is focused strictly on computation. It does have to advance the practice of what it is we're trying to do as a discipline.
Thank you. Mike?
I am the retired editor-in-chief for ACM Transactions on Mathematical Software. TOMS is a very old journal. It has a lot of tradition and history, including the collection of algorithms, CalGAL, and most recently, as part of my editor-in-chief role, I established what's called the Replicated Computational Results Initiative, RCR. RCR sets up a separate review process for the results in a paper. And so in addition to the traditional review process, the results of the paper are reviewed in an open review with someone who is a practitioner in the field of mathematical software. So this would be someone who can judge, the delta advance in global knowledge, but could really look at the results in the paper, or do they make sense relative to their broader knowledge of mathematical software. TOMS is about mathematical software research. So certainly there's an algorithmic part to the papers that are submitted, but it's also about software design, doing a good job of designing software. So software artifacts have always been a part of TOMS. In fact, I served on the editorial board for ACM CISC and JPDC, but TOMS was the one that really I thought was ready for this kind of next step in reproducibility expectations. Also, just because I think it'll matter in the conversation, I was co-chair of SC17 technical papers with Anne Benoit, and as part of that process, we had two appendices that we would accept that were related to reproducibility. And I'll stop there.
And Thomas, in order to get us off on the right foot, would you like to expand or refine the conversation so far just to set the framing?
Yeah, so I'm not representing a journal. Obviously, I'm also not representing the PASC conference, so that would have to be you or Thorsten. I would say I represent the PASC program. So PASC stands for Platform for Advanced Scientific Computing, which is a program in Switzerland to fund software development at universities, and which includes all the major universities in Switzerland, including Basel, Zurich, Geneva, Bern, Lausanne, EPFL, and ETH Zurich, and I'm also a professor at ETH Zurich. We are very much concerned in this software development. So I think what we can say is we may have a path or a contribution here in Switzerland how to sustain software development at the not just at the front side of the application, but also at the back end between the applications and the supercomputers. So that was the main concern of our effort here. PASC also is a major supporter of the PASC program of the conference, and one of our main ideas of this conference was to get the work we do, but also the various collaborations we have across Europe and Asia and the US disseminated in a serious way. So that's why we support this conference. And we introduced the paper track last year after we had a discussion. So there was a vague idea to try to bring together computer science way of publishing into the domain community and introduce this idea of not just submit papers, they get reviews, you may be able to rebut, but we would like to introduce a way to have a full review cycle where the authors can, in a conference setting, revise their papers, and then the revision gets discussed by the panel. And actually the person who gets all the credit there is Thorsten Höfler, who who really, it's one thing to say this in general, but then you have to implement it, and he actually implemented it with David Keyes last year, and that was a major tour de force, but I think they were very successful last year, and the fact that you guys were again successful this year shows that, he did a good thing, and this is somehow a model that we can sustain and probably scale. And then, we had this discussion for a lot of domain scientists, having a publication in a conference, no matter how good the conference is not satisfactory. So we need to move, we need to really help the step to take the conference paper into a full journal paper. And so that's, now a year ago we started this discussion about engaging journals, and you've done a wonderful job in getting the discussion going. I had little to do with it, so the credit is with all others here. But this is really a model that we need to somehow figure out how to implement now. And I'm not sure we're there yet, but I'm looking forward to the discussion.
The next question I thought we should take up is just an assessment, briefly, of how well we're doing at documenting rigorously what we do and how we do it, such that it would be exposed to a broad community and possibly improved as a result of that interaction. So I'd like to ask the domain scientists here who are journal editors just to answer that question briefly. Is your community doing a good job of documenting their software, their data practices, so that others could understand it, completely understand how well it's been done, possibly even reproduce it? So who would like to start?
I can go.
Yeah.
So for TOMS, so far we are doing a good job in a voluntary way, that we are accepting papers, that where the full scope of the environment is exposed, it gets reviewed. The reviewer has to actually step through the entire process. They actually publish their report as an article in TOMS, and so that provides them with some real tangible incentive for doing a good job. But it's still voluntary, right? We're not even close to making all papers do this. In supercomputing, it's similar. If you want to move to that, just briefly, it's voluntary. The CISC and JPDC, there's really nothing in place. So as a broader sense of our community, we're really just stepping out into this kind of, elevated expectation.
Robert, Walter?
Well, I'm talking about, is this on? Talking about the astrophysics community, as far as I can tell. Maybe that's not fully complete. It's very patchy. There is only voluntary things, and not everybody actually publishes their code. Not everybody publishes a code paper. And they're definitely, I think as astrophysicists not very much concerned about this in terms of reproducibility, because we will not trust the result before it has not been sort of reproduced with various different codes and methods. So that is, I think, our validation procedure. If the same code produces the same result on different machines with different people, that's not really very interesting, because the physics model is the same, and maybe same errors there. So I think this is not so much of an issue, this reproducibility in astrophysics.
So I think that's also true in the earth sciences. I would say that at least in James, we would want papers that ask not only what we do and how we do it, but why. That's quite important, again, because our goal is to advance the practice of modeling as a whole. A fair amount of what we do is sort of almost, well, they're not heroic computations in the sense of some of the presentations you've heard in plenary so far, but there are computations that no one will reproduce in the sense that you were describing, where you run the same code on a different machine and look for bitwise reproducibility or something. This is, I think, not a main concern. Again, the question is understanding the physical environment in which we live, and that understanding would arise because you would see robust behavior across modeling systems. That being said, our journal, like all the AGU journals, requires a statement of data availability. This is, I guess you could call it aspirational. We, in principle, require everybody to make their data available. In practice, that is often sort of swept under the rug. But it is something that we think about, particularly at James, moving forward. And I can talk about that or elaborate on it if it becomes relevant.
So what I'd like to do now is just pause and see if any of the things we've talked about so far strikes a resonance in the audience. If anybody would like to make a comment or a question at this point to fill in any gaps that we have, or point what you think is really important about the conversation so far. Any questions?
Oh, this is no fun. Oh, they're great.
Do you have any estimates for how much time is spent in maintenance of code versus writing it? I mean, I'm an old person, so I remember numbers like 85% of the effort in commercial software is maintenance.
Developer time?
Yeah, or whatever, just human time.
No, I don't have an estimate. Does anybody is anybody aware of a study or?
Well, yeah, I mean, generally speaking, you're right. I mean, the estimates are 70 to 80%.
Yeah, that's what I wondered.
70 to 80% of the total cost of a successful product goes into maintenance, and that's not just fixing things, but perfective maintenance, right? That's improving it. That's moving it to the next platform. Moving to the next compiler, right? Living with the more rigorous interpretation of the standard, and now code that used to compile doesn't compile, right? These are all activities that fall under this maintenance category, and it's a huge amount of time.
Well, for something like TOMS, it's usually relatively short papers. But something like a Monte Carlo simulation of spins or something, these can be enormous codes. And
well, the research papers in TOMS often represent enormous codes.
I see. Okay.
So software bases. So there are two categories of papers: algorithms, which is where you publish usually a short paper along with the software that also gets reviewed. But then the research papers, which are actually the majority, maybe 75 to 80% of the papers, are about products, often open source, often available if not open source, to the broader community. Otherwise, it wouldn't really be reusable math software. Those are often about complex, commercial quality, production quality software. That tends to be quite large. But
well,
yeah, it's
one
a
of the
huge
reasons
cost.
we're worrying about this is nobody pays for maintenance in a university, and
it's not a line item, but they pay for it.
They do, absolutely.
Yeah.
Any other questions or comments?
Well, the programs like PASC are about, if you include in maintenance advancing to new architectures, that's exactly what they are about.
Okay, we have a question right here.
So similar to what Wes was talking about, who pays for the data availability? Would the journals, say, part of your page charges and subscription fees, would that go toward, maintaining an archive, or?
So CPC, for example, publishes your data, which is the software other data, and this is now guaranteed essentially to be published and kept forever as in a repository. It's an Elsevier thing, actually. Elsevier has this repository, which called Mendeley, where they sustain it. And so that is not like you put it on GitHub and then you don't know what happened to it eventually, but so this is a way to make it available forever.
Data sets tend to be significantly larger.
We still have software from '69, if you want to analyze it.
That's more mature than the earth sciences can claim to be. I think that what you raise is exactly the point that people bring up all the time, which is, I'd be perfectly happy to make this data available, but tell me how to do that in a way that's sustainable. It is sometimes, many of these computations are done in facilities like yours, and the ability of the facilities like yours to provide such an archive would be a very valuable service. I would say.
there's a lot of discussion about this in the context of the European Open Science Cloud. And there was a workshop, I think June 12th, that was public. You can go on YouTube and see those discussions. And I think the policies are quite clear. The expectation is the universities pay for this. So there may be the journals have a business model to do this, but the universities are responsible for the work that their scientists do, and they have to provide the means. In Europe, at least, I know that may be bad news for some of the university presidents or rectors who are listening to this, but it's their responsibility to make sure the funds are available. Now, that doesn't mean that they have to do this in an expensive, campus IT type of thinking way. There is a different story how you implement it in an economic way. And then in Europe, there's discussion around the European data infrastructure for this. But the responsibility is with universities and research labs. Very simple.
I think generally speaking that any of these advances in trying to improve rigor they cost something, right? And we have to figure out how to support that, how to integrate that cost into our overall model for moving forward, and it may involve splitting or sharing those costs in general, but it's part of the price that you pay for sustainability. And we have to be willing to accept that. And it has to be, in a certain sense, uniformly applied, otherwise people will be at a competitive disadvantage. Because some will have to pay for it and others won't.
Joost has a question.
Yes. So I have a question to the earlier remark made by the panelists that the interest in reproducing the same result with the same code, maybe on a different architecture, is limited. And I'm really surprised by that remark, because I think in our field, it's actually very difficult to reproduce even, a paper with results. You need to have much more information than is available in the paper to get close to reproducing that result. And in some sense, just making, for example, inputs and code available is a very effective substitute to providing all data. Because my simulation might produce, a terabyte of data, but the inputs and code that describes it is, a couple of megabytes. So I think it's very important that reproducibility and making data available start at that level, because it's more valuable than just the data.
I didn't say that.
No, you didn't. Those two guys.
those two did. But I think it gets a little bit to the sense of what one means by results. So first of all, someone who comes to me and says, I don't want to provide the output from the simulation, but I want to provide the code and the inputs, I would say that would be terrific. Thank you very much. That satisfies the request quite completely. Mm-hmm. What we mean by results is a new idea, right? And so it's not bits. It's a new idea or new understanding. And so this is maybe where, and I suspect that's true in the astronomical community as well.
I think what the authors should provide is the physical input model, not the numerical details, not the random seed that they use. It must not depend on that. If it result critically depends on that, then it is not interesting or it's bogus. And so the reproducibility issue, of course, is therefore, I think, from the physical input to the physical output. It must not depend on numerics. If it does, we don't trust it. And therefore, I think we really in astrophysics, we only trust the result if this map from physical input to physical output can be reproduced with completely different type of maps.
I think that's great. It's of course the ultimate goal, but there is a level in between, I think, that is a first step of getting to your higher goal.
So I would actually, before when you introduced the journals, I realized I have here an editor of CPC. And when I was a PhD student 25 years ago, and I got started on the code, I had a physical review letter that was published. I had 2 physical review B articles, and I had a CPC paper for that code, and I had then because the code, and I think it was even 2 CPC papers for that code. And it was maybe hard, but because I had to learn Fortran, I had a different training, and I was, but I could reproduce. And and recently I had my students work on a paper, again, submitting to CPC, and I realized that CPC has still the rigor of the 20, 25 years ago, and they have also evolved, so they are fully modern now in terms of how I would release software and so on. And I've been asking now a question. In the meantime, our community, material science, or condensed matter physics, material science for those who don't know, brags about having the most cited papers in physics and so on. How many that cited papers in terms of references of codes, how many of these are in CPC or journals that have an equivalent rigor? And so my question to you and to, I don't know if Nicola Mazzari is in the room, and to all my colleagues down there, at least in material science, and all conscious colleagues in other domains, is why are we not publishing this? Why was this the case 20 to 30 years ago, and we're no longer doing this, but we are still very proud of all the citations we get for, I would say, not so rigorous publications.
So I would like to add to this that my most cited paper is in CPC, so.
Good for you.
Okay, so maybe we move forward with the conversation a little bit. The next question I envisioned was to hear from our journal editors on any initiative or change agenda that they are executing, any vision for the future that they want to share with us that might broaden the conversation about what your specific journal is doing. So maybe, Robert, would you like to begin?
Well, I would describe 2 things. One of them is driven by the sort of publication community, and the other is driven by the practitioners in my community. On the Geoscience side, there's an initiative which is a little bit hard to get a strong handle on, called the Geoscience Paper of the Future. And what I think this amounts to in the end is DOI, so Document Object Identifier, sort of the publication handle or the publication unit for code and for data. And so roughly speaking, the idea there would be that one would be able to publish along with lists of citations to journals, lists of citations to code, and lists of citations to data sources. I think this is terrific. I'd love to encourage my authors to do this. The support on the back end from the journal and from the society has been a little limited. I intend to push that forward. About a quarter, maybe a third of what gets published in James relates to fairly large climate simulations that you've heard discussed here, particularly on the first day. And here, a lot of that work is coordinated by the World Climate Research Program, roughly speaking. And they have, and a lot of that stuff winds up in IPCC, so the Intergovernmental Panel on Climate Change reports that you've probably heard about from the news. And there's been a very strong effort to also create these DOIs for each data set going in, each simulation output coming out, and for each set of code. That's very heavy, but I think it's going to be very effective.
I think I have not much to say here. There is no plans in the sense that I'm aware of. There is this repository library that supports software sustainability. I'm not quite sure it is actually taken much. In my personal field, astrophysics, this library is not important, really. So the vast majority of codes used in the astrophysics community, this library has not a role to play at the moment. That may change in the future. And so these people essentially manage their software themselves in their own way.
In ACM, so I already mentioned the replicated computational results, review of results independent of the standard review. But more broadly speaking, ACM has a badging system now available. The three most pertinent ones are artifacts available, which you can get a badge on a paper if the artifacts that were used to produce the computational results are available to the general public. Artifacts evaluated means that someone actually interrogated what was available, and then the RCR badge. And so that as broadly speaking, those are incentives for the community to invest because of the recognition that you get. There's also an ACM reproducibility committee that I'm part of to kind of talk about these issues on an ongoing basis, trying to further improve our ability to incentivize people to do good work in this area.
Okay, so on to the next question. So what, from your point of view, what may be the opportunities for journals and a conference such as this to have a mutually beneficial relationship? What may be the value to the community broadly, to your journal, to a conference from interactions? What comes to mind?
I can tell you that in my own work, one of the things so roughly speaking, if the computational people don't publish in journals that I or my colleagues read, then we don't know what you're doing. And I'm struck at how much is being done that, roughly speaking, is not, many places in the earth science are not aware of. So in particular here in the mini symposia on weather and climate, I've heard a lot about domain-specific languages. I don't think I've ever seen a paper in a geoscience journal that talks about that idea, and yet it seems crucial to how our modeling will advance. So I'm here, roughly speaking, trying to harvest papers from y'all to publish in my journal, because I think that my readers want to hear about that.
So I think this is a very nice setting, not unlike supercomputing in terms of the model, although I think Thorsten has advanced what's possible in terms of revision capabilities. But the journal process is longer in span. I think it gives you the ability to get a first version of a paper and really substantially improve it through the review process. I know that the review process for TOMS provides tremendous value. I'm sure it does for your journals as well. And we can take a paper that's rough and has a seed of a really good idea and shepherd it along through that. And so I think journals can take as input papers, maybe even rejected papers from a conference setting, rejected because there was just too much of a change required to match the deadline required for the conference, and turn it into something really valuable. I see that as a real opportunity.
I think that's the single thing that journals do best, in fact, is improve manuscripts that come in that are not clear.
Yep.
So again, I'd like to engage the floor. Is there a value add from having this broad exposure to talks from many different perspectives? Can we improve work because it's presented here? It certainly can be improved through a two-stage peer review process. This is very intensive, and a lot of people put a lot of energy into this. When the work is presented here, are we also improving it and moving it forward? And if so, where does it go? How is that improvement documented? Anybody have any comments or questions?
How is it? Well, go ahead.
Sorry, I just want to ask a question to Robert's remark on inviting authors writing more about code or coding into an applied science journal like yours. In the end, what individual scientists are after is citations as well. So is it really for somebody who develops a DSL for a climate model the clever move to publish in James rather than a more technical journal in terms of citations he's going to get? And how can you, as an editor, or you as a group of editors, make sure that the benefit for that you can encourage people doing this, but how do you make it transparent that they get the right benefit, the right return from publishing in one journal versus another?
So it's a very fair question. How does one push for change in the incentive structure? At least at the AGU, one of the things we can do is give some extra love to certain papers. So highlight them in various forums. They have people who tweet and they have people who Facebook things, and we sometimes write commentaries. And we do this when we think that there's a paper that someone might overlook. And so it may be that you would get more citations in a more technical journal. It might be that your idea would get greater uptake when addressed to people for whom the idea is new, but nonetheless valuable. So of course, I don't have a perfect answer for that question, but just to say that there are times that we publish. First of all, I think that the ability to discover relevant manuscripts outside the journals you happen to read, that's gotten a lot easier. That's also part of it. Yeah. Maybe I'll just stop there.
Walter?
I think you started almost our next point here, which is getting recognition for code writing in the domain sciences. And of course, James is a domain journal, whereas CPC is not a domain journal. It's essentially a journal which serves that purpose of publishing software across all the physical domains, right? So an astronomer, for example, would usually not read CPC. And there are code papers acceptable in domain science papers, but they are not really well received in terms of citations. So there's a cultural problem in domain sciences, at least as far as I'm aware, that publishing code papers is not really giving you a good career start. So it's not done well, or it's not appreciated properly in the community.
There's many people who write codes in the audience here. I just ask you to imagine, do you know where your results should be published, and is it obvious, or is it a puzzle where your innovation should go? I know when I interact with the users of our facility at Oak Ridge and I talk to them about documenting their results, sometimes they know very well where to go with publications, and I can look in our publication record and know that some of these journals represented on the stage are frequent venues for our users. But I also have other users, when I would talk to them about this innovation, are you going to document it? They say, well, we can't get this kind of stuff published at all, right? There are domains that had no answer for where the results could be published, right? I think a conference paper provides one venue, if that could be embraced. Are there other thoughts?
What we are trying to do for the next conference is that we have the conference will accept papers, I think, on a monthly basis. Well, we have to discuss because you have to implement it, but the conference accepts papers on a monthly basis and reviews these papers on a monthly basis. And then there is a cutoff when the papers that have been submitted to that point are considered for the next conference. So this should accommodate the fact that scientists usually don't write papers for a deadline at the conference, but they write papers when they are ready. If we have this, and we have this connection to the domain journals, then we somehow have to have the discipline to really publish our software in these journals. And I think one way, I'm happy to get input from particularly my Swiss colleagues here, but I think there is a way to do this. Is next time we review the PASC program, there will be one thing that you have to check, namely whether you published or not published the software.
Mm-hmm. I see a question from Joost.
Yeah, so maybe I can connect to that. At some of the big centers, when you submit a request for a grant, the question is, will you publish this in Nature of Science? And they're talking about the results and not the software, because the software we don't get in Nature of Science usually. So I think that kind of question is giving the wrong incentive to publish software papers. I think we publish software papers and they are highly cited, but they are usually in journals with an impact factor like CPC, I don't know, 3 maybe?
3.9.
Yeah, 3.9. And these don't get listed in annual reports, and they are not the kind of journals that are being requested in grant applications, and they're not the kind of journals that are being honored in searches and things like grant proposals. So I think the problem is there much more than whether journals exist where we can publish these papers and whether these papers are highly cited. I think the journals exist, the papers are highly cited after 5 or 10 years, but they're not in the journals that are being recognized.
Mm-hmm. So let me be clear that I'm talking about the PASC program that is not the program that allocates CSCS. So the PASC program could require from its PIs that the software gets published, open source, and the publications go with journals. And I'm certainly not going to request that the software is published in Science or Nature. It's published in the journals we discuss here, of course. But I agree with you that there are many, many papers about software that have a lot more citations than your typical Science and Nature paper.
I got into the reproducibility effort because I wanted to see a better investment in high-quality software. I would talk with people and you'd say, well, I'd love to do a better job with software, but what's my incentive? It doesn't help me get publications, doesn't help me get money, doesn't get me recognition. Why should I bother? And so I did the reproducibility stuff because I wanted to provide incentive. We put language into funding opportunity requests for that, and we're trying to create thought leaders in these areas to elevate the importance of this kind of activity. And I think it has a broad impact if we can do it.
Thank you. I would like to come back to Thomas' remark about publication of code. So first, I completely agree that we are funded on public money, so it's European or Swiss money, and that what is done with that money should be also public. So personally, I'm in favor of open source and publication. But then you said this should be bound to a publication in a journal. And in my opinion, this is not the right way. So you're trying to mix the two things. So on one side, you have a journal publication with a review process, with difficulties of finding the good reviewers. It takes always longer and longer. While with the publication of the code, you would like the people to use it. And then maybe you have also feedback from these users. So if you publish a code and this gets used, this is your recognition. So I would like more to have a link between the users of a library or a code and its value, and not of two reviewers who maybe are not good enough in compiling my code, then says, no, this is not publishable.
Thank you for your comment.
So actually, there is a question in there. So what you are asking for, I think we can bring together my requirement that the code be documented in a journal properly, with proper peer review, and the release attached to that journal. And CPC, this is one thing that I noticed was new compared to 25 years ago. They have a way to frequently update and actually you get a new, I think, DOI or a new.
Yes.
And now the question is to CPC how we can make the triangle, so not just this between, what I understand, between the developers who publish in CPC, but you have a triangle between the developers, CPC, as an example, if you have similar mechanism, and the users of this library or code. I think that's what you are looking for. I think that's something we need to think about.
There's a question here.
I'm just going to comfort a little bit the gentleman who just commented earlier, but in terms of publications, when you're confronted, you're not a computer scientist, but a computational scientist, and you develop your code, what is important is that you need to publish. Either it is for a grant or it is for yourself. When you are implementing a type of code, sometimes it's not often that you're going to make something so revolutionary that it deserves to be published in a computer science journal. Sometimes you're just implementing the theory better, but it's not very innovative. It's just you're doing it the way it should have been done. So we're confronted on either publishing the science in Science PRL or the high impact journal, or then you find yourself confronted to smaller journals with an impact factor of 1 that require a lot of work. So often you just say, well, I'll do that later, and you never publish your code. The second aspect is that then you have the conference journals where you have deadlines, as you said, and often it's 16 or 10% of acceptance rate. And because you are just doing a better implementation, you get rejected by saying, well, what is the innovation here? And then you have to wait for another conference or another journal, and you find yourself just with your code. And of course, at some point you need to publish it. But one of the aspects that I find interesting with things like GitHub, where you can share your code, I find it's more valuable to write a good manual of your code, describing your code, and putting your code on GitHub. And whenever you have to cite it, you just cite the link of GitHub, and inside you have a good documentation. I think that is an alternative, or at least I think that's an alternative to having the difficulty of publishing your code in a journal.
Yeah. Yes, but it's not a citable item. So you really we want to be citable. But there are some journals which essentially accompany that. So there's a journal for open source software or open research software, which essentially publishes a 5 to 8 page summary of your code, nothing more, and you put it on GitHub, and that's it. Of course, it is reviewed, so it is scrutinized, but there are journals around which would essentially you get your citable thing together with your GitHub repository. So this exists.
I should say that in my journal, we would not be the place where you would publish your code, but as I said, we would like a DOI for that code ideally. And that we don't have a way yet of distinguishing, but I hear that maybe this is important. We don't have a way of distinguishing whether that DOI comes from a journal that's committed to providing some continuity for how that DOI is resolved, or whether it's just something from Zenodo and GitHub and you're going to click on it and hopefully it's going to be there. Yeah.
Let's take here. Wait a second. Here and then there.
I'd like to follow up on something that Joost mentioned about the high impact factor journals. You know, I mean, Nature and Science have had some major scandals of fake results. That's not to say all of them by any means, but like he was saying, you know, there's a sort of a wrong incentive here to publish in a high impact journal, which is going to have a high visibility and may not be right. And we're somewhere in between experiment and theory here, and we should at least be able to reproduce our results. I mean, this to me seems extremely important.
Yep.
I mean, are we doing science here, or are we just doing television, you know?
I think you should also defend how you produce your software, how you maintain it, how you guarantee regressions, you know, detection. So, how do you train and document? All these things should be factors that go into the quality of your work.
Yeah, and there should be some incentive for this. I think that's in part.
And some funding agencies are. If you look at BER in the U.S. proposal, funding opportunity announcements that are computationally oriented, they request a 2-page description of your productivity and sustainability plan, where they ask you to describe exactly these things.
But how about the provenance, things like compiler switches and which version of the operating system, all that stuff should be documented.
Yeah, absolutely.
And only in recent years have there been any requirements for
That's
this
right.
stuff.
But what I'm hearing is from the comments, besides programs like PASC that actually fund software maintenance in the sense of moving to new architectures, the user programs like CSCS, which I direct, has a user program, and the user program of Brace, which we have, I think, heavily influenced. Our Maria Grazia is sitting there, and I will speak about that tomorrow afternoon. Those user programs should require or should give a big bonus to applications for time on the machine to those who can reference a code that has been published in something like one of these journals and that has proper documentation out there. And so we need to pick this up in how we verify this in our technical review, because potentially this helps our technical review. And this is something I think I take out of the discussion, and you can contradict to me now if you think this was a misunderstanding of your suggestions. Otherwise, we will have this discussion.
Another question from Axel.
Yeah, thank you. I have one question on the idea of publishing a version of a software. I mean, what usually happens over time is that you find bugs or that someone improves your software. And for example, Zenodo allows you to link your software release with a new version, which might be crucial. Do you have plans to implement something like this in journals?
CPC publishes version announcements. And depending whether it's a major or minor one, it will be reviewed or not, actually. So it will go through a peer review process, in fact, if it's a major revision. And it will be updated in the library and everything, and get a new DOI, etc.
Part of the TOMS effort is to do exactly that, to tie a specific version to the published results. And then most of the software is actually readily available externally. We're talking about things like, Harwood subroutine library, FFTW, PETSI, and packages like that. So they are regularly updated. But you don't publish a new DOI for it.
So our hour is almost up, so I hesitate to take on the fifth question I wrote down. Maybe we should just allow any remaining discussion from the floor or from the panel to come forward before we conclude our hour. Anything else that, something clever, something you think the rest of us need to know, but you haven't contributed it yet? So I'm very aware of the outcomes of the user program at Oak Ridge. I'm the one who's asked to give account for that. And I can tell you that of the top 25 most cited publications, 10 of them are for those that are associated with produced reference data, 10 of 25, and 2 of the 25 are associated with published codes. Right? Wow. Right. And that's in terms of the traditional metric of citations. Now, those are not the only kind of outcomes we try to achieve with our center. We try to achieve very broad outcomes, including industrial users and other things. But I think that citations is one thing that should be valued in terms of the reuse. So if I count that as a data artifact, then I can say 50% of our top 25 most cited papers are associated with a data artifact of one kind or another, right? Mm-hmm. And some of those are in journals with high journal impact factor, others are not, right? But nevertheless, the outcomes have been documented in the literature, and then their utility has grown through these, the documentation of their utility has grown through the traditional measure of scientific citations. And I have no reason to think that in that regard our center would be any different from any of the other major centers. Okay, so I'd like to thank the panel for participating in what might have been an unconventional conversation, but one I think that was hopefully mutually beneficial. I want to thank the audience for participating with their ideas and questions, and I look forward to the public lecture in a half an hour. Thank you very much.